Okay, cool. I just want to get a sense of the room. Who's a developer here? That's awesome. That is amazing. Who's like a very new developer here? Okay, so like half the room-ish. Okay, cool. So my talk's going to be pretty much targeting the people who just raised their hand. It's going to be more of an introductory kind of overview of the ecosystem and kind of what all the things are that you've heard someone say, but you're like, of course, yeah. Of course I know what that is. Of course I know what Web3 is. You know, like, and so I'm going to try to give you a good overview and to go relatively slowly. So if I go too fast, feel free to stop me. All right, so I want to do a couple things. So I want to explain the workflow. So if you want to build a Dapp, what exactly do you have to do? Like, what are the steps involved from going from like an empty, like code editor to an actually running thing live in the world that someone else in the world that you don't know can like call? And so that's the main goal for that. But along the way, I really do want to explain the tools that people keep talking about, like what is MetaMask, what is Truffle, what is like all these things. And basically the short answer is you can go Google it, like it's really not that complicated. But it's always good to just have like a place to start so that you know what to Google, essentially. And then I also want to talk about some common terms that you might be hearing, like what is like IPC, RPC, what is like all these other things. And so I guess we'll just jump into it. So the general overview to build a Dapp is first you have to code a smart contract. That's the stuff where you're using Solidity, which is the programming language that is the most popular in Ethereum. And so once you've built that smart contract, it's just sitting there on your computer, right? It's not really doing anything. And it's just in text, right, in code. And so most people are not building applications in code for other people to use a command line to interface with. So step 2 would be to build like a front end of some kind. And typically that's either a website or like a native app that you have to download and host a node or whatever. And then the third step is to kind of connect everything together and then put it on the blockchain, either on the mainnet or the testnet. It's the same process. But before we jump into those exact steps, I do want to establish a couple fundamentals. I know this may be too basic, but this is kind of a more technical definition of it. So a blockchain is a cryptographically secure, transactional, singleton machine with shared state. So breaking that down, it's kind of useful if you do it. So cryptographically secure, I'm not going to go too into, but everything is cryptographically done. So every step along this way is at some point cryptographic. And then transactional singleton machine just means that there's a state. There's like an Ethereum state that changes over time if you throw transactions at it. And then that state is shared across everybody, right? And so that's pretty much all of blockchain in a nutshell. And Ethereum is one such blockchain. So another way you can say that in a much shorter way is that it's just a transaction-based state machine, right? And obviously you guys are probably computer science people, but for those who are not, a state machine just refers to something that takes in inputs and then something changes. And then that's the new thing. Yeah, so. And then that's done using this mathy looking thing, and that is called a Merkle tree. It's got a couple different names, and you can spell tree like T-R-I-E. It's the same thing. And so essentially what this is, it may be a little overwhelming for some people, but the bottom part is just data, right? It's the data that you want to like put together somewhere. And if you think of data as having, each file as having like a fingerprint, then you could kind of put two things together, and that becomes a new type of data, and then that new type of data has a new fingerprint. And that fingerprint is unique to that exact set of data. So if you change a single bit in there, the whole fingerprint becomes different. And so if you can take the first bottom left part and the next one, and you put them together, that creates the one above it. And then that one above it also has that fingerprint, and that's unique to that, which is composed of those two inside of it. And then if you do that to all of these, you can do levels of that, and each level is another fingerprint. And if you change, for example, at the top one, the root hash, if you change anything at the bottom level, like you change one bit in the bottom one, the entire root hash also changes. And so that's a way to make sure that the state that you think it's supposed to be at is what it actually is at. And that's the basis of the whole blockchain state management thing. Cool. Everyone's still with me. I can see that, so that's good. Okay. So in terms of account state, right? So Ethereum uses something called accounts, which is different than its predecessor, like Bitcoin uses something called a UTXO, and a UTXO that stands for unspent transaction output model of dealing with transactions. I'm not going to go into that too much, but Ethereum uses an account, and that account consists of 4 different components. And I'm going to talk about nonce because I'm sure you guys have heard that word many times, and maybe you know that it's just a number, but it's actually kind of confusing because miners also use a nonce, and that's also just a number, but it's a different kind of use case. So for the account side, a nonce, as the gentleman 2 speeches before was saying, is it's tracking how many times you've done something, right? It's just like a counter. You can think of it as a counter. So if you create a new account, you start at like nonce 0, right? And you send someone something, you're at nonce 1. You send a different person something, you're at nonce 2. It's really pretty straightforward. But that's for if you're like a wallet address. If you're the other kind of address, if you're a contract address, it's just counting the number of contracts that were created by that contract address. I know that's a little bit confusing. Like if you don't get it, raise your hand. Okay, cool. All right, and then the balance is just pretty straightforward. It's how much ether you're holding. And a lot of ether, you may have seen WEI, W-E-I, and that's just like 0.1801 ether. And that's what typically gas is calculated in, or like GWEI, which is like a millionth of an ether. All right. And then a storage root is that root hash that we saw on the previous slide. And then the code hash is just the hash of the EVM, the Ethereum virtual machine itself. The Ethereum virtual machine, you may know already, is just what we call this thing that resolves the coding of Solidity into bytecode. Cool. All right. And so as I mentioned before, the reason why we use that whole Merkle tree thing is essentially so that you can put in all these inputs and know for sure that the output you're expecting is what you're getting. All right. All right. So Ethereum transactions themselves, I just want to kind of show you what they are and kind of that there's 2 kinds. One is just like the regular message call, and then another is to create a new contract by itself. So those are the only 2 real categories of transactions. And inside of each transaction is all of these things. So you just learned what a nonce was. It's just a counter. And then there's both, I'm sure you guys know gas limit and gas price, which are different. So the gas, yeah. I'm sure you guys know that, I hope. So that's the amount you have to pay to the Ethereum network so that the miners will execute the code that you're sending them. Okay, and then the 2 and the, yeah. So the trickiest part of this whole thing is actually the V, the R, and the S. And that's a little bit more complicated, but you use all of those just to sign the transaction. That's all right, that's a more detailed description of everything that's in there. I will send these slides out. I have tweeted them if you guys want them. And then I also sent out a more descriptive document that kind of also goes with this, and it will explain what those are. Yeah, I'm going to give you guys a second to read what you want, because I know people like reading slides. All right, cool. As I said, I'll send these out, and they'll be available for you to read through. And also, you can just Google it. All right. I think it's really interesting just to see that all you have to focus is on the top part. You just have this externally owned account, and that's just your wallet address. It's external to Ethereum. So your wallet is not inside of Ethereum. It's on your computer. It's outside of Ethereum. And so that externally owned account sends that previous thing of that transaction, that package of stuff, to a contract address. What you're actually doing is you're calling like a procedure inside of that contract, but you could just think of it as you're sending it a transaction. And then inside that, it gets executed, and then so you could talk from like your wallet to a contract, but contracts can also talk to each other within the Ethereum within Ethereum. I'll just say it that way. Cool. This is really interesting, and so you can go a little bit deeper into that, but I will, for the sake of time, move forward. So that was my overview portion, and now I'm going to kind of fast forward through the rest of this. But so going back to those phases, right? First, you have to code the smart contract, then you have to build the front end, and then you have to connect everything together and then deploy it, right? And so typically what you want to do when you are building something out, these are the steps you want to take. And if you take nothing away from this except for this is good. So first you want to set up your environment. We'll go into that in a second. Then you want to code the Solidity contract. Then you want to create that front-end application, deploy the application online, like on the website side, and then point your website front-end to the Ethereum node. And there's multiple options for pretty much all of these steps. And then once you've done that, your Dapp is live and other people can talk to it. This is a little bit, I'm going to skip this slide. What this is just talking about is all the different options that you have between, it's the differences between a traditional web application and like a decentralized application. And so one thing that's maybe worth pointing out is that the database function in like a traditional web app is kind of not there anymore. You substitute the blockchain for it, but you might also just want to have some sort of like hash. So you might have like a web browser-based database, and so those are becoming more popular lately just for this application. But there's also a lot of other ways you can do it, but that's like the most basic way. I do want to point out that there are other programming languages because everyone's like, oh, only Solidity. But there are others, but they're just not as good. And there's a reason why like almost everybody uses Solidity over the alternatives. There was one called Serpent a while ago, but that's pretty outdated now. And then there's one called Viper, which is gaining some traction, but not really. And that's more of like an experimental language. So you should just stick with Solidity because everything's much easier. And as I was talking to someone outside about, there's a lot of, Ethereum has probably the best ecosystem in terms of like onboarding new developers into learning how to code stuff. And that's made possible by a lot of these tools that are built for your convenience. And so one such thing is Truffle. I'm sure you've heard about that. And that's a framework to build smart contracts, but you can also do a lot more with it than that. You can test inside of Truffle. You can like deploy inside of Truffle. You can do a lot inside of there. So if you're a really new developer into the Ethereum ecosystem, you should look into Truffle and just master that, and you will get like 99% of the way there. And then when you get more advanced and you need something more special, you can step back and then code your own like tools or whatever. Cool. All right. I'm going to really go through these. OK, so that's how you get Truffle. You just npm install it, and then you do that to it. You can Google that. And then the other things you might want to look for is, so Ganache, it kind of goes with Truffle. So instead of like having to deal with real nodes and stuff, this will just make a pretend node. And then you can kind of code all your stuff inside of this like pretend environment. And then you can go to testnet. And then you can have other people like call it like using fake money, but otherwise pretty much the same as a real application. And then once that's kind of proven, you can then take it to mainnet, and then that's like real money, and you should get like code audits and stuff if you're handling money. But yeah, and so Remix is also, I'm sure you guys have heard of, and I'm sure you guys have probably played with it if you've coded it all. But you just go to that website, and it's both of like an IDE and a like play button kind of. So like if you like code a button or like an input that you need to take in, it'll just create that for you automatically. So it's almost like taking that step 2 portion and doing it for you, like the create the front end portion. Kind of does that, not fully, but good enough for most applications. One thing that a lot of people get wrong in the beginning is that you don't have to worry about deterministic like code in traditional web apps because your computer can handle it. But smart contracts need to, at some point, be mined on a block. So you do have to have code that like stops running at some point. And then at that point, they can update a block. And then a really big tip, if you are going to get into coding, is to use Solidity events. Just trust me and Google that and use a lot of that in your code because it will. So one big thing is that it can save you gas cost, and that is good enough for me. So, I'm going to skip that. You can Google that. I'm going to skip that. You can Google that. One big thing is Web3. That whole second phase, all you need to know is get really good at Web3. Like, understand what it is, and then you'll be fine on this entire step. It's just, you can install it using npm and then import it into your stuff. And then all it does is it tells the Ethereum node, whichever one you're using, to talk to your smart contract. So that bridge between like blockchain and web app is handled by Web3, or services that are using Web3, or like doing something along that bridge. I'm running out of time, so I'm just going to show you the last. Geth is the Go Ethereum client, and so you should just use that all the time. That's whenever you see someone coding and there's like a command line that they're talking to like the Ethereum node about, that's Geth. They're using Geth. And then the big thing between these two is that one IPC RPC is for your local machine only. And if you're going to talk to like a website at all, you're going to probably use like JSON RPC. That's all that means. And then there's options and commands. That's how you do that Geth stuff. And then ABI is the application, it's like an API for blockchain. And then you just need those two things, the application binary interface and the contract address. And I'm pretty much out of time. So I'm just going to mention like shout outs to Infura, which makes your life easy, MetaMask, which also makes your life easy. And oh, this formatting did not work. But yeah, I'll send that out. You can read that. And light nodes are awesome. Less secure, but they're awesome in like making life easy. So that's just the review. You can read that later. This is just that first slide again. You can read that later as well. Cool. I think that's it. Thank you, guys.